So the game that we're programming a game. It's called the guessing game, and it would work kind of like this. So Logan pick a number, or I'm picking a number between 1 and 10. Pick, choose. What do you think? Too high. Too low. You got it. That's what we're programming. Okay, it's gonna work just like that. It's gonna be fantastic. Okay, it's super exciting. But we gotta start somewhere. All right. Before we get into that too far, I want to make sure we know a few formal definitions of some things. Okay. So we have a few things that are called logical operators. Okay. Everything on this page evaluates to a true or a false. So when you run the program, after performing these operations, the result is going to be a true or a false. So, for example, if in math you said 5 plus 2, what would the result be? 7. This is not an example of something that evaluated to true or false. This is something that evaluates to 7. Right? Does that make sense? But if in math you did 5 greater than 2, what would that evaluate to? True, right? That's a true statement, so that's a correct statement. If I wrote 5 less than 2, that would evaluate to false, right? Okay, so these are the types of things that we're talking about when we say they evaluate to a true or false. Is something less than that? Is something equal to that? Is something greater than that? Is something not equal to something? That's what we're going with here. So, we're going to formally define all of these things. Okay. The first thing that we have is this exclamation point, right, Trevor?
Yes.
Exclamation point, and this one means not. Okay, and the exclamation point is kind of like that little circle. Remember when we were talking about all the logic gates and stuff? A little circle and it negated something. That's what the exclamation point is doing. And this operation is just like the logic gate for not. Okay? It takes in one input, it flips the value. So if I had something like not 5 less than 2, okay, parentheses, so it's going to do that first. What's 5 less than 2? True or false? False. Okay, so this is false. Then I put that exclamation point right in front of it. What is it going to become? True. So this would evaluate to true. Kind of tracking? Kind of see what's happening? Okay. The next one is a double and symbol, and this is an and. Okay, hopefully kind of easy to remember. It's an and. So it acts just like our and gate. It takes in 2 inputs, and it outputs 1. So it takes in 2 trues, 2 falses, a true and false, and it outputs either true or false. Okay? So this would be like if I had something that said, if 5 is greater than 2 and 4 is less than 7, then what it would do is it would evaluate this side and it would say, what is that? Is that true or false? True. It would evaluate this. Is that true or false? True. 4 is less than 7. Okay, so it's true, and the and means they both have to be true, so in the end it would evaluate to true overall. Kind of making sense? Yeah? Okay. Should I hear a no?
Yeah.
Are you joking with me? Or are you?
No.
The next one, this is 2 vertical lines. They're right underneath the backspace. So look at your keyboard. You see the backspace? Right underneath it, you see the 2 vertical line. It looks like it's like 2 dashes, kind of, but it's a circle. Okay, that's a vertical line, and that's your or. So remember, it looks kind of like a rocket ship. This is or. And it would work the same way as this. You have an expression on either side, and you put the double vertical lines in the middle, and if at least one of them is true, it will evaluate to true. Okay, is that kind of making sense?
Yeah.
Sort of?
Yeah.
Okay. The next thing I want you to see are these relational operators. Okay? Relational meaning they relate things. They say, how do these relate to each other? Are they less than each other? Are they, like, is this one less than that? Is this one greater than that? Is this one equal to that? So they relate to things. Does that make sense? And again, they evaluate to a true or a false. I've already kind of used these in the explanations of the ones above, so hopefully it's making sense. So what is this one? Math class, what is it? And okay, so I know some of you are like, maybe math isn't your favorite, and you have always just kind of like, yes, it's a 50-50 shot, is it greater than or is it equal to? Okay, I think of this as an alligator. Almost everything in my life I think of as an alligator. Okay, I'm from Louisiana, so it makes sense. All right, the bigger side, like this is your alligator. It's eating the bigger number. It's going to eat the bigger number because that would make it more full, right?
Yeah.
It's eating the bigger number, greater than. Cool? Okay. Less than is, don't even worry about it.
It's the same.
I just want you to remember, yeah, it's the same thing. Like, it's eating the bigger side.
So 4.
It's eating the bigger side. Okay, if that confused you, just ignore it. It's fine. The good thing about computer programming is that if you ran it one time and you noticed that it was wrong, then you could flip it, and then it would be right. Okay? Cool. So this one is greater than, this one's less than, greater than or equal to, less than or equal to.
Equals.
Okay, equals, and then this one, what do you think?
Non-equal.
Okay, so this one's not equals, and this one is equal. Okay, I have one thing I need to make sure that we understand. We'll have a few things, but one thing really important, super important. Okay, we have a single equal sign, and we have a double equal sign. Okay, single equal sign, we call this the assignment operator. Okay, I just stopped it off. Assignment operator. Okay, this one was a relational operator. Okay. Want to make sure that we understand the difference. So if I said x equals 5, I am assigning the value 5 to the variable x. I am saying x is 5. Okay, I'm saying x equals the value 5. Like, I am making that a true statement. Okay, I am making it true always because I am saying x now equals 5. Does that make sense? Okay. If I said x equals 5, and then in the next line of code, I said x double equals 5, this is saying, is this true? This is saying, is x equals 5? Yes or no? True or false? Okay? So, is x equal to 5 if x equals 5?
Yes.
Yeah, so this would be true. Okay, now if I made it 4, then it would instead be false, right? Does that make sense? The last thing that's super important is a lot of people will forget the double equals when they put it inside of a condition. So if you say if x equals 5, okay, what is this doing? It's assigning the value 5 to the variable x, right? So that means that x will always be 5 when this code executes, right? Which means that this will always evaluate to what? It will never not be true, okay? It will 100% of the time, this will be true, which means what's inside your curly brackets will execute. Okay, which is that what we want to happen when we have an if statement? Do we want it to execute 100% of the time? No, we want it to only execute if the condition is true, right? Jaden? Right? Only if that condition is true, which means that we always really want this to be a double equals. Right? We always wanted to say, well, is x equals 5? Right? We don't want it to say x equals 5. We wanted to say, is it equal to 5? So the double equals is your question mark, asking a question. Single equals is assigning a value. Okay, does that make sense? Okay, so let's start thinking about guessing game. Wait, did you say what? Like, you have a question?
Like,
No, it's okay. Ask it. Please ask a question.
I mean, like, I guess it makes sense. I'm just trying to figure out how we were writing the code.
Just like that. Yeah, like if x double equals 5, it's asking a question. If x single equals, it's taking 5 and putting it into the variable x. Okay? Isla?
Yeah.
I can't right now. Okay. So if we're going to make the guessing game, remember the guessing game was I guess a number, I say Tracy guess the number 1 through 10, 2 high, 5, 2 high, 4, 2 high. You got it. Okay, that's the guessing game. Okay, that's what we're trying to do here. What's our step 1? Like, if I were to write the steps out for how the guessing game works, what's step 1? What? Yeah, guess a number, like have a number be like selected, right? So select answer number. So like actual number, the missing number, the secret number, the hidden number, whatever you want to call it, like the number that we're trying to guess, like pick it. Okay? What would we do after that? So I picked my number, and I said, Brandon, pick my number. Like, what's the step 2? What? But all we've done so far is select my answer. But when we played the game, I said, what do? We asked a question. So we say, guess my number. So ask user to guess the number. Cool? Does that make sense? I hear like keyboards like chirping like a lot, and I'm just writing on the board. So don't really, I mean, maybe you're taking notes, that's fantastic, but like I'm a little concerned by the number of, okay. So what's step 3? So we picked a number, it's in my brain, and then I said, Brandon, guess my number. What's next? Wait for a response, or he guesses, right? So like the user guesses. Okay, what happens next? User guesses. But like, how do I know how to respond? I compare, right? Like I compare the answer to the user guess, right? Okay, so I compare. And then based on the results of the comparison, then I provide an output or response, right? So compare, option A would be what? What? Like it's too, like they guessed too high? Okay, so too high. What would option B be? Too low. Okay, so now I have different things that I need to do. So if they guess, well, let's start with if they guess correctly, what happens? We say, congratulations, you win, and the game's over, right? So, yay, game over. Right? Like, yay, you win. It's over. Okay? If they guess too high or too low, then what happens? Ask them to guess again, right? So where do we go up to? Okay, so what is this looking like? A loop. Woohoo! Okay, so we're going to need a loop, right? We're going to need a loop. We're going to need some if statements. That's what this looks like, right? So compare. We have different conditions that might be true. It could be too high, too low. It could be equal, right? So based on this outline, we're going to start programming. So in BlueJ, create a new class, your last name underscore guessing game. Your last name underscore guessing game. So we imported our random number generator. Now we're going to use it. So we can say random. I name it rand every time. Equals new random. So what I'm doing is I'm creating a random number generator named rand, and I'm initializing it. I'm just assigning it the initial values that it would need. Okay. You could name this Bob. You could name it like whatever you would want to name it. You could name it. But I name it rand because that way every time I use it, I know that I'm talking about my random number generator. Okay? The variable name helps me understand what it's being used for. Okay? After this, we need to use it. Okay? So when I'm picking a random number, when we play this game, 1 through 10, right? What type of number is being picked? Like, what are you trying to guess?
Integer.
A whole number that is an integer. Perfect. So, int is what we needed to create. And I'm going to name it answer. That's the name that will always be the number that was randomly picked by the computer that I'm trying to guess. And when we use a random number generator, we do next int. Okay, it has an open close parenthesis, and the way that this works is I need to type a single number into it, an integer. Okay? I'm going to go off for a little bit, and we're going to talk about how this works. Okay? Okay, so that was an int. We called it answer equals rand dot next int. Ooh, that's how you spell int. Open close parentheses, and we have to put a number inside of those parentheses. Like that's what we're trying to figure out. We don't know what number to put in. Okay. If I put in 5, what that's saying is pick from 5 number options. So it's always going to start at 0 because in computer science we're weird. We start at 0, not 1. Okay, so it's 0, 1, 2, 3, 4. That's 5 number options. Okay, so if I put a 5 in there, it's going to pick from one of these numbers only. Okay, so it's saying from your first 5 choices, pick one. That's what the random number is doing. Random number generator is doing. Okay, if I put a 10 in there, then it's going to pick from the first 10 numbers. So it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the first 10 choices. So it's going to pick between 0 and 9. Okay, 0 is not, like when we play the guessing game, Dad, is 0 normally included? Or do we normally say like 1 to 10?
Yeah,
1 to 10, like nobody picks 0, right? Like if you do, you're weird. So we don't really want to include a 0 in here, right? What? No, say what you would say. Is it a guess?
Int 0 equals 2.
No. Okay, so here's the thing. Like, I know intuitively what I would want to put into this parenthesis up here, intuitively, I would want to put, like, you're like, okay, I want a number 1 to 10. Like, why can't I just write 1 to 10? Right? Like, wouldn't that make sense? That's not what we can put in. So it's not an option. We have to put just a single number into the parentheses. So between 1 and 10, how many choices are we talking about? 10, right? So if I put 10 in there, it's going to give me 10 choices, and it's going to go just like this, one of those numbers from 0 to 9. But instead of 0 to 9, Jaden, I actually want it to be 1 to 10, right? So I want it to be 1 to 10 instead of 0 to 9. So let's look at our start and end numbers. Like, how do I get 1 from 0? How do I get 9, like 10 from 9? Add 1. So, what?
Would it be next line 10 and then plus 1?
Yes, next int. It's next int. But I clearly didn't spell that right. Okay, so, yeah. So what's going to happen is we're going to say, okay, pick a number between 0 and 9 by putting the 10 in there. So, rand dot next int. Put a 10 in there. And then, so that would pick between 0 and 9, right? We understand that? If I put a 10 in there, it's picking between 0 and 9. I really want it to be between 1 to 10, so what I'm going to do is after I do this, I'm going to add 1. So I say, okay, pick a number between 0 and 9, and then add 1 to it, which means that if I picked 0, it would give me what? 1. If I picked 1, it would give me 2. If I picked 2, it would give me 3, 4, 5, 6, 7, 8, 9. If I picked 10, I would add, or 9, it would add 1, and it would give me 10. Does that make sense? Okay, so it's always going to start at 0 by default. The number that you put into the parentheses is the number of choices you want to give it. Okay, a lot of times we're going to be like, pick a 1 or a 2, like pick between 2 choices. Okay, that's something we do often, so it would be a 2. How many choices do you have? 2. In this case, we want it to have 10 choices. We want it to go between 1 and 10, that's 10 options, so we put a 10 in here. But then we have to figure out how to get it to the range that we actually want it, and that's when we add. Making sense? Yes. Okay. So in this case, in our program, we want to put what in here? 10, and we want to add 1. Okay, so this will give me a number between 1 and 10. When we finalize this program, it's not going to be between 10, it's 1 and 10, it's going to be like 1,000 or something in mind. Okay, so looking at our list here, we selected an answer, right? Selected that answer. We did.
Yeah, it's like
So the answer is different every time?
Yes. Because if it were the same every time, would that game be fun? No, it would not be fun. Okay, so that's how we would pick our random number answer. After that, the next step that we have listed is we want to ask the user to guess the number. So this is where we would be like, hi, welcome to the guessing game, guess the number between 1 and 10. Okay, so system.out.println, welcome to the guessing game. Guess a number from 1 to 10.
What's up, Yes.
Okay, after we ask the user to guess, what do you think we need to do? So what comes after me asking you a question? You answer it, right? So I have to get the user's response first. Like, I can't just ask a question and then immediately start doing stuff because I don't know what their answer is. I don't know what their guess is, right? So first step, we need to get the user's guess, okay? In order to do that, what do we need to use? We don't need ifs yet. We need a scanner. I heard somebody say that. Well done. So we need to import our scanner. Because otherwise we can't read and understand what the user's typing into the terminal. We need to know. So we need a scanner. We can declare an initializer scanner. So scanner scan equals new scanner. Do we put something in the parentheses for scanner or not? User text was just a variable name from our last program. What, Brandon? Yeah, system.in. So remember, when we create a scanner, we have to tell it what it's reading from. What did I do wrong?
Do we have to do import Java?
Yep. Java.util.
Oh, I didn't see that.
So we create our scanner. We have to tell it where to read from, because we could read from a string. We could read from another file. We could read from a bunch of different places. We have to tell it read from the terminal. So this is just like that out, system.out, but it's system.in. Okay. When I'm scanning in a number, what type of number is it? an integer. Like, they're not guessing decimals, right? So int guess equals scan dot next. What do you think? So remember, if we did scan dot next line, that's going to save a string. So I'm going to get an incompatible types if I try to save it as an integer. What do we put here instead? We talked about it on Friday. We could, did somebody say double?
Yeah.
Double would give me a double variable type. So double meaning it can save a decimal. So what do we think it's going to be? An int. So scan next int. Okay, so this is going to take the next integer that it reads. It's going to save it into the variable guess. That is of type integer. So we selected our answer. So we randomly picked one. We asked the user to guess a number. The user can guess now. So now the hardest part is just we have to compare all this stuff, right? So we have to compare, is it too high, is it too low, is it correct? So for a second, let's talk about if statements. Okay, so you've used if statements. We did that in some of our programs. Now that you're a tiny bit familiar with it, I'm going to try to formally explain it to you, okay? So we have an if. Everything that ends in an if is going to have a condition. Okay, the condition goes inside of the parentheses. So this is your condition. A condition will evaluate to true or false. It's saying if whatever this is true, then run this code, right? The condition goes inside of the parentheses, okay? After the parentheses, we have a curly bracket to open and then a curly bracket to close, and that's saying this chunk of code goes with this if. So if this condition is true, run the chunk of code between the curly brackets. Making sense? Okay. So we have ifs. So let's say I put, let's say up here I have x equals, that's weird. Let's see, in the code I have an x, it equals 5. I put it in there. Okay? In my condition, I could say, well, if x equals 5, run some code. That makes sense? Okay? This should not always be true, which is why we have 2 equal signs. That means, is this true? It's asking the question. Is x equal 5? Okay? So that's an if. You could have tons and tons of ifs all next to each other. And I could come down here and I could say, well, if x is greater than or equal to 5, run some code. Okay? This, if x equals 5, is this statement true? This condition is true, right? So whatever is in here would run, right? And then if it was immediately followed by an if statement that said if x is greater than or equal to 5 and it had some code, would this one run too? Yes, it would, right? Because it's an if. They stand alone. They're isolated. They do, it checks it and it runs it. Okay, if I put an else if right here in front of that if, and now I have this if, and it says if x equals 5, do this. If x is greater than or equal to 5, do this. What would it do? Like, let's see, code 1, code 2. What would it run?
Code 1.
Just code 1?
Yes.
Yes, it would only run code 1 because the way that else ifs work is it says, well, if this one is true, skip the rest of them. Like, they're linked together, and only one of them will execute. Like, only one in that whole section. That make sense? Yes? Okay. So, and they have to be in this order. You have to have an if first, and then you have else ifs. It's basically like saying, if, like, so-and-so is doing something, then I'm going to do this. But if they're not doing that, I'm going to do this. Right? Does that make sense? The other option that we have is we have something called an else. Okay, else's do not have parentheses because they don't have a condition. Okay, they don't have the open close parentheses like the else if and the ifs did because they're linked to something else, right? It's like if you said, I'm going to draw a circle. And let's say there's this like, this spot right here is the value 5. Okay, like that means x equals 5 if it's there. And then there's a section right here, this red. This is x is greater than 5. What is the other possibility? Right, is there any other option? Like, can x be anything else? No, x can be 5, it can be greater than 5, or it can be less than 5. So what this else is saying is, well, if it's not equal to 5, do that. If it's, let's say this was the greater than only. If it's greater than 5, do this. What condition is going to be else? This is if it's equals, this is if it's greater, this is if it's less. So you don't even have to specify it with a condition because the only possibility is that it's less than 5.
Right.
Does that make sense? Kind of? Okay. No. I got another one. I got another one for you. Ready? Number line. Ready? Carby, this is for you.
Okay.
Okay. That's 5.
So, the first one, that's like if we were right. The second one.
And this is kind of like, yes, you can apply it to guessing game. It is the same example, but I'm trying to just do this like as like a non-related example, but it is an example. I'm just saying, if x equals 5, do this. Like, this is not related to guessing game. Does that make sense? Okay. Here's my example. So you've got 5 on the number line, right?
Right.
Okay. Your possibility is that it can be 5. It can be greater than 5. Or it can be less than 5. Can it be anything else?
No.
No, it can either be less than, equal to, or greater than. Like, there's no other option. There's no other, like, possible answer. Right? So I'm saying that you can do this as an if, an else if, and an else. The else would just catch everything else. You don't even have to define a condition for it. Does that kind of make sense? I still see some like super confused looks.
It makes sense.
You're just saying that so that I keep moving.
No, actually.
Okay, fine. We'll do it in a second, but I just want, like a lot of times, sometimes it's easy to specify one part of an equation. Like it's easy to say, like if the number equals 5, like that's an easy equation, right? If x equals 5. But sometimes it's not easy to specify, well, like anything else, right? So like it's either 5 or it's not. Does that make sense? And sometimes the else just helps us catch things without having to define what criteria it would meet. Does that make sense? Like you don't have to define every single condition. You just have to find enough that the else would catch everything else. Don't worry about it. Okay, so next we've got, so we created it, we have a guess, and now we have an answer. The next step that we have to do is we have to compare them, okay? So let's do this with an if. And let's start with if guess equals answer. What does that mean? If the guess is answer, what is that? You win, right? Like you guessed the number properly. You're a winner. Ding, 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 right? Okay. If you didn't win, then guess might be greater than your answer. That's not how you spell guess. Guess could be greater than answer, right?
Yes.
That kind of, you see that? Okay. Remember, the reason why I like the else is because if this is true, then it doesn't even check this. Like this could never be true at the same time that this is true, so it's not worth the processing time. It's not worth actually checking this because you know that they can't both be true. Okay? So we're saving time in our execution of the code. Okay? The last thing is, well, if it's not the answer and if it's not greater than the answer, then what is it? Okay, so you should be able to, at this point, figure out what goes inside of these, because you're smart people. Okay, what should you do if you got the answer right? What should you do if you didn't?